In audit sampling, statistical or non-statistical, we apply a procedure to less than 100% of a population and draw a conclusion about the population. In non-statistical sampling, the auditor uses their professional judgment rather than statistical techniques to determine sample size. Statistical sampling allows auditors to measure and control sampling risk, which helps design efficient samples, measure sufficiency of evidence, and objectively evaluate the sample results. Statistical sampling quantifies the risk that the results from the sample are not indicative of the population. Sampling risk is the risk that the auditor's conclusions based on a sample may be different from the conclusion they would reach if they examined every item in the population. Non-sampling risk is the risk pertaining to non-sampling errors. It can be reduced to low levels through effective planning and supervision of audit engagements. Stratification is a technique of dividing population into relatively homogeneous subgroups. For example, if we have a population of accounts receivable, we may decide to create 3 strata. All accounts $10,000 and over is one strata. The second is accounts $5,000 to $999.99. And the third is all under $5,000. We then would determine our sample size for each strata. Because the 3 strata by themselves are more homogeneous, stratification results in a smaller sample size, thus increasing the efficiency of the audit. Here are 3 types of sampling plans. Attribute sampling determines an occurrence rate. Discovery sampling, we look to discover at least one deviation. This is useful in identifying fraud. In variable sampling, we determine a dollar amount. There are several forms. We will review the mean per unit estimation. We will go over examples of attribute sampling and variable sampling mean per unit estimation. The allowance for sampling risk is an amount used to create a range set by plus or minus limits from the sample results, within which the true value of the population characteristic being measured is likely to lie. It is also known as precision. The larger the allowance for sampling risk, the smaller the sample. In other words, the wider the interval, we are more confident, but less precise we will be in conclusion. Using an attribute sampling plan, we test items to determine if a control is working. It's a yes or no. We establish an occurrence rate known as the deviation rate. When testing a control, the auditor is concerned with 2 aspects of the sampling risk. The risk of assessing control risk too high. This is the risk that the auditors will assess the control risk higher than it actually is. A control is working, but the sample results say it is not. This affects the efficiency of the audit, as the auditor will overcompensate and do more work than necessary. The risk of assessing control risk too low This is the risk that the auditor will assess the control risk lower than it actually is. A control is not working, but the auditor's sample says it is. This affects the effectiveness of the audit, as the auditor will undercompensate and do less work than necessary. In attribute sampling, confidence is the complement of assessing audit risk too low. If confidence is 95%, then the risk of assessing control risk too low is 5%. Here are the audit steps for using attribute sampling for a test of controls. 1. Determine the objective of the test. 2. Define the attributes and deviation conditions. What makes an error? Define the population to be sampled. 4. Specify the risk of assessing control risk too low and the tolerable deviation rate. 5. Estimate the population deviation rate. 6. Determine the sample size. 7. Select the sample. 8. Test the sample results. 9. Evaluate the sample results. And then 10. Document the entire sampling procedure. Let's go through an example using attribute sampling to test a control. 1. Determine the objective of the test, which we're going to say is, do receiving reports match the invoice from the vendor? Yes or no? 2. Define the attribute and deviation conditions. What constitutes a deviation? In other words, what constitutes a non-match? 3. Define the population to be sampled. In this case, we're going to use account payable vouchers number 1 through 3,653. You must specify the risk of assessing control risk too low and the tolerable deviation rate. We're going to say the risk of assessing control risk too low is established at 5%. The tolerable deviation rate is the maximum population rate of deviation that the auditor will tolerate without changing their assessment of the internal control. Based on the auditor's judgment, we set that rate at 7%. Now we need to estimate the population deviation rate. The auditor must estimate the expected population deviation rate. Auditors often use sample results from previous years to establish this rate. Based on the previous years, we will estimate it at 1.5%. Now we determine the sample size. Rather than use complex formulas, sample size can be determined from a table designed to test controls at a 5% risk of assessing control risk too low. Our expected population deviation rate is 1.5. Our tolerable rate is 7%. This indicates that we result in a sample of 66 items which must contain no more than one deviation to achieve the 5% risk of assessing control risk too low. Let's select a random sample. We then test the 66 items in the sample. Let's assume we have no deviations. We now evaluate the results. Go back to the slide that we used to determine sample size. Remember, it indicated that the allowable number of deviations was 1. Since we had 0 deviations, we can conclude that our sample, that there is a 5% risk that the population deviation rate is greater than 7%, the tolerable rate. In this case, the auditor's testing supports the auditor's planned assessed level of control risk. You could go to a second table to determine exactly what your achieved upper deviation rate at 5% risk of assessing control risk too low is for 3 deviations. Use sample size of 65 and number of deviations 3. As you can see, the achieved deviation rate is 11.5%. This would cause the auditor to increase their assessed level of control risk in this area and modify the nature, extent, and/or timing of their substantive testing. We now will go over an example of classical variable sampling, mean per unit estimation. Here are the steps. 1. Determine the objective of the test. 2. Define the population and sampling unit. 3. Choose an audit sampling technique. 4. Determine the sample size. 5. Select the sample. 6. Test the sample items. 7. Evaluate the sample results. And 8. Document the sampling procedure. We now will go over an example of classic variable sampling, mean per unit estimation. Let's begin by defining the sampling risk for variable sampling. Variable sampling is used to estimate a dollar amount and is used in substantive testing. The risk of incorrect acceptance is the risk that the results of the sample will indicate that a population is materially correct when it is materially misstated. This affects the effectiveness of the audit because your audit is ineffective. This is serious. You are saying the financial statements are materially correct when they are not. The risk of incorrect rejection is the risk that the results of the sample will indicate that a population is materially misstated when in fact it is not. This affects the efficiency of the audit because you end up doing more work. For our example, population size will be 100,000 accounts. The book value of the population is $6,250,000. We set tolerable misstatement at $364,000. We set the sampling risk for incorrect acceptance at 5% and the sampling risk for incorrect rejection at 4.6%. To compute the allowance for sampling risk and sampling size, we will need to know the risk coefficient for sampling risk for incorrect acceptance of 5% and incorrect rejection of 4.6%. These are 1.64 and 2.0 respectively. The planned allowance for sampling risk, ASR, is computed by dividing the tolerable misstatement by 1 plus the incorrect acceptance coefficient divided by the incorrect rejection coefficient. 364,000 divided by 1 plus 1.64 divided by 2 equals 200,000. We need that number in order to move on and compute sample size. Sample size equals population size times incorrect rejection coefficient times standard estimated deviation divided by the planned allowance for sampling risk. Notice the effect of the standard deviation on the sample size. In this formula, as it increases, the sample will increase because this would represent more variability in the population. The planned allowance for sampling risk is the opposite. The bigger the allowance, the smaller the sample. 100,000 times 2 times 15 divided by 200,000 equals a 225 account sample size. Let's review how the various factors affect sample size. An increase in the risk of incorrect rejection decreases the sample size. An increase in the risk of incorrect acceptance decreases the sample size. An increase in tolerable misstatement decreases the sample size. An increase in the population size increases the sample size when the population is small. An increase in the standard deviation increases the sample size. An increase in the expected misstatement increases the sample size. This one is actually for probability proportional to size sampling, which we don't go over in this class, although it is covered in the textbook. We confirmed 225 accounts. The book mean of the accounts confirmed is $63. The audited value of the accounts confirmed is $61. The difference is $2. In this case, the auditor's estimate of the population is $6,100,000. $61 times 100,000 accounts. The allowance for sampling risk is $200,000. $2 times 100,000 accounts. The adjusted allowance for sampling risk equals tolerable misstatement minus population size times the incorrect coefficient times the sample standard deviation divided by the square root of the sample size. $364,000 minus $100,000 times 1.64 times 16 divided by the square root of 225 equals $189,067. As we mentioned, the auditor's estimate of the population is $6,100,000, $61 times 100,000 accounts. And the allowance for sampling risk is $200,000, $2 times 100,000 accounts. We can compute the acceptance interval by taking our estimated audited value of $6,100,000 and adding and subtracting the adjusted allowance for sampling risk of $189,067. $6,100,000 plus the $189,067 equals $6,289,067. The $6,100,000 minus the $189,067 equals $5,910,933. Our book value falls into this interval, thus indicating the account is not materially misstated. Let's go over some concept check exercises. When using variables mean per unit estimation sampling for each of the following conditions, does sample size increase or decrease? A. If you increase the risk of incorrect rejection, the sample size will. If you increase the risk of incorrect rejection, the sample size decreases. B. If you increase the risk of incorrect acceptance, the sample size will. If you increase the risk of incorrect acceptance, the sample size decreases. C. If you increase the tolerable misstatement, the sample size. If you increase the tolerable misstatement, the sample size decreases. D. If you increase the population size, the sample size. If you increase the population size, the sample size increases. And E. If you increase the allowance for sampling risk, the sample size. If you increase the allowance for sampling risk, the sample size decreases. Here's one more relating to variable sampling. F. If you increase the standard deviation of the population, the sample size will. If you increase the standard deviation of the population, the sample size increases. When using attribute sampling for each of the following conditions, does sample size increase or decrease? G. If you increase the tolerable deviation rate, the sample size will. If you increase the tolerable deviation rate, the sample size decreases. H. If you increase the expected population deviation rate, that's the error rate, the sample size. If you increase the expected population deviation rate, the sample size increases. If you increase the risk of assessing control risk too low, the sample size. If you increase the risk of assessing control risk too low, the sample size decreases. And finally, what is the effect of population size on sample size in an attribute sampling plan? Population size normally has no effect on sample size in an attribute sampling plan, except for very small populations of 150 or less.